So guys, after the cathode ray experiment, let's discuss about the specific charge. Now guys, after the cathode ray experiment, Sir J.J. Thomson found the specific charge on the electron, and the specific charge is denoted as E by m, where E is the charge of the electron and m is the mass of the electron. Sir J.J. Thomson only said that the charge particles in the cathode rays are electrons, and he found the specific charge of the electron. And how he did it? Let's try to understand. Now this is the model which can make us understand how J.J. Thomson found the specific charge on the electron. So you can see that this is the cathode ray tube. This is cathode. A high voltage battery is there. Anode is there, and cathode rays will move from cathode to anode, or you can say that cathode rays will originate from the cathode and will move to anodes. It will move towards anode. Since anode is perforated, means there are holes in the anode, it will pass through anode. And if yes, now these two plates are positive and negative, it means he want to show that there is an electric field, right? And this is a magnet, so due to this magnet there will be a magnetic field also. Now let us consider these plates are not here and magnet is also absent. So what will happen? When cathode rays will start from cathode and it will pass through anode, it will go in the straight line, and since the electric and the magnetic field is not there, it will keep on moving and it will strike on point number 2 on the fluorescent screen. Means that there will be no deviation on that particular electron beam, that is cathode rays. Now another case, if electric field is present which is perpendicular to the direction of the cathode rays, then what will happen? Now cathode rays will come in this direction. Since there are electrons present in the cathode rays, they will be attracted by the positive charge. So since they will be attracted by the positive charge, it will move towards the point number 1. So at the point number 1, they will strike on the fluorescent screen since positive charge is there on the top. Now, if you remember, electrons are there, they are the negatively charged and they are going in the upward direction towards the point number 1. If electric field is not there, magnetic field is present, then it will move in that direction where a negative charge is expected to move. That is, they will move in this direction. So if there is electric field, cathode ray will move towards the point number 1. If there is magnetic field, it will move towards the point number 3. And if there is no field, then it will move towards the point number 2. And if we adjust the electric field and the magnetic field in such a way that their forces are equal, then also the cathode ray will go towards the point number 2. And if they are equal, we can find the charge by mass ratio. The same thing J.J. Thomson did, and he found the value of E by m, and the value of E by m was 1.758820 into 10 to the 11 coulombs per kg. That's how J.J. Thomson found the specific charge on the electrons. Let's find out how Millikan found the charge on the electron. Now guys, Millikan's oil drop experiment. Robert Andrews Millikan, he found the charge on electron. He performed an experiment and found the charge on the electron. Let us understand what was that experiment and what was the setup of that experiment. Now, this is the setup of that particular experiment by which Millikan found the charge on the electron. So what he did, he took a chamber. In that chamber, there are two plates, you can see. One is positive, another is negative. Then there is electric field in between these two plates. It's quite obvious because there is one positively charged plate and other is negatively charged plate. Now in the positively charged plate, there is a hole present in it. So we will discuss about this hole later on. After that, he took an atomizer. In atomizer, you can see that there is some oil and he sprayed some oil in the chamber. And when he sprayed that oil in the chamber, some oil drops were falling under the force of gravity. All drops will fall under the force of gravity, but some are moving into this hole and they are falling inside. Now, let's concentrate on this oil drop. Now what we will do, we will pass X-rays from this region. X-rays will ionize the air, it will form gaseous cations and it will form some electrons, right? Those electrons which are coming from the gaseous molecules and gaseous cations are formed, the electrons will get stick on this particular oil drop. And if on one oil drop there are electrons, the oil drop will become negatively charged. Since it was moving downwards due to the force of gravity, this oil drop will become slow in the movement. Why? Because it will be repelled by this negative plate. And with the help of this telescope, we can find the velocity of this particular oil drop and we can find the relation between the electric force and the gravitation force. So on this oil drop, if you take this oil drop here, on this oil drop, mg, that is the gravitation force, it's exerting downwards and charge into electric field, that is the electric force that is exerting upward. So with the help of these two forces, Millikan found that the charge on the electron is minus 1.6 into 10 to the power minus 19 coulomb. That was the Millikan oil drop experiment. Now let's see how they determined the mass of the electron. So the mass of the electron, Millikan said the charge of the electron is minus 1.6 into 10 to the power minus 19 coulomb. And according to J.J. Thomson, the specific charge of the electron is 1.758820 into 10 to the power 11 coulombs per kg. So the mass of the electron will be, we can find it by dividing the charge of the electron by the specific charge. That is, if we do E divided by E by m, E and E, that is the charge of the electron, will cancel out and we will get the value of the mass. And this is the value of the mass, and that is 9.1094 into 10 to the power minus 31 kgs. So that's how they determined the mass of the electron. Let's study about the anode rays.